to go over the last 4 problems on the back of the worksheet for you today. I first identified that I have a root at x equals 2. I have a vertical asymptote at x equals -1 and x equals 5. The fact that I have the root at x equals -2 gives me a factor of x minus 2 in the numerator, and the vertical asymptotes give me factors of x plus 1 and x minus 5 in the denominator. The only thing I need to check is the y-intercept. That would mean when x is 0, y would take on a value of 2 over 5. Negative 2 over negative 5 is going to reduce to 2 over 5. And when I look closely on the graph, it appears that that is a possibility. I was given no other information, so I'm going to assume that this is an adequate representation. The second problem, again, I've identified the horizontal and vertical asymptotes. The horizontal asymptote is y equals -2. Vertical asymptote is at x equals plus and minus 3. So my denominator has my x plus 3 and x minus 3 for my two vertical asymptotes. I noticed that I had a root at 0, and in fact it's bouncing, so it has to be an even power. Since the denominator now is an x squared, it works out that with the numerator being an x squared and the denominator being x squared, I would have a horizontal asymptote. I still needed it to be -2, and without inserting this -2, it would have been a positive 1. So when I put in the -2, it changes that horizontal asymptote to be -2. Still gives me roots at 0, vertical asymptotes at plus and minus 3. The third problem. Again, as much as I could, I identified I have a vertical asymptote at -2, another vertical asymptote at x equals 1. It appears that it crosses the y-axis at 0, -1, and the x-axis at -1. Crossing the x-axis at -1 gives me a factor of x plus 1 in the numerator. The vertical asymptotes give me x plus 2 and x minus 1 in the denominator. I squared both of them because, as you notice, on both sides of these vertical asymptotes we're traveling in the same direction. So we learned earlier in the unit that that would require these to be even powers. Finally, I needed a -4 here because when I inserted 0 to verify my y-intercept, without the -4, my numerator is 1, my denominator is 4, and I need it to be a -1. So if I multiply 1/4 by -4, I would get that -1 that I desired up here. The last problem is one of my favorites. I gave you the information for the slanted asymptote. So just reviewing a little bit of algebra, my numerator divided by my denominator gave me my slanted asymptote. So I ought to be able to divide my numerator by my slanted asymptote to figure out what the denominator is. I can look at the graph and determine that there's a bounce at 0 and a cross at -1, which gives me a numerator of x squared times x plus 1. Now remember, instead of dividing by the numerator by the denominator, we're going to divide the numerator by the slanted asymptote in the hope of figuring out what the denominator is. So I went over here and I did just that. And when I multiplied 2x squared by 1/2 x plus 1/2, I get x cubed plus x squared. So then I wrote that out as this is my numerator. This result here, remember we said this is not going to be our asymptote this time, this was going to be our denominator. And so I'm trying to verify that. And I realized, gee, I can factor out an x squared of the numerator and the denominator, which means this simplifies to x over 2 plus 1/2. Well, at first you might think that makes sense, but remember what that's indicating is that your graph would now look like that line with a hole at 0. And certainly my graph does not look like that. So what I need to do is I need to have some constant here so that when I bring this down here, that's not in terms of x, it will keep me from having no remainder, so that I would not be canceling this out as I did here. So what I'm going to do is I'm just going to say that that is, my denominator is 2x squared plus some constant. I chose it to be 1. Finally, I have x cubed plus x squared divided by 2x squared plus 1.